Chavi Bansal and I have a YouTube channel called Magic Mentor. So yesterday on that channel I shared a question from the rotational motion, and as you can see in front of your eyes, that same question is there, right? So let's read out the question and understand what the question is asking us. A uniform rod of mass m and length L. So it is talking about this uniform rod of mass m and length L. Okay, this is the complete length L, leans against a frictionless wall. So this is frictionless wall, correct, with quarter of its length hanging over a corner. So quarter means L by 4 is hanging here and 3 L by 4 is present here, right? Friction at a corner is sufficient to keep the rod at rest, means this corner is providing a friction which is sufficient to keep this rod at rest. Then the ratio of magnitude of normal reaction on rod by wall and magnitude of normal reaction on rod by a corner. So for this wall, that frictionless wall, the normal reaction will be in this direction. Let us name it as N2. Okay, and the normal reaction by this corner will be in this direction N1, which is perpendicular to it, right? What are we supposed to find out? We are supposed to find out N2 by N1, right? Now the main point which is given here is we have this frictional force is sufficient to keep the rod at rest, means the rod is at rest. Okay, now before we apply everything, let's see what all forces are being acting. So this is a frictionless wall, so there is no force acting here, only normal reaction. At L by 2, mg will be acting in a downward direction, where L by 2 length, sorry, this is completely L by 2, so this will be L by 4, right? Now there is this point is providing the friction, so friction force will be in the backward direction. Let us label it as Fr. So these are the forces which are going to act. Now the first thing to do in such type of question is to resolve the forces in the same direction, means either downward in this axis or the axis in which the normal reaction is present. So let's solve in the horizontal and vertical components. N2 is already in horizontal. N1, if the angle here between the rod and the corner is theta, then this angle is also theta, which will make this as N1 cos theta and this direction N1 sin theta, right? Same way we can resolve Fr here as Fr cos theta and here Fr sin theta, correct? Now the question says the rod is at rest, means what? The rod is in rotational as well as a translational equilibrium, right? Why rotational equilibrium? Because there are forces acting but it is not rotating. The forces which can provide the torque is there but it is not rotating. It means it is in rotational equilibrium and it is not sliding also, so it is in a translational equilibrium as well, right? So let's apply. So there I have drawn this diagram again to make you understand what all forces are there, right? So for rotational equilibrium, the total torque has to be 0, right? So the total torque has to be 0. Let's take a point where we are getting the minimum forces. So if we take this point, then only N2 will be neutralized, right? We will have multiple other forces, but if we take this point as reference, it means N1 and frictional force both will be neutralized. Only N2 and mg will be responsible for providing the torque. So let's take this point labeled as A as the point where we are calculating the torque. Now at point A, N1 and Fr, which is frictional force, is neutralized because it is acting at the same point. It cannot provide the torque. There are only two forces which are providing the torque. One is mg and the other is N2. Here mg is the force which is acting, which can cause the clockwise motion, whereas N2 is the force which is acting, which can cause the anti-clockwise motion. So therefore, to have the net torque equals to 0, we can equate mg into its distance. What is the distance from the point of reference? So if this is L by 4, right? This is L by 4, again theta. So this length will be L by 4 cos theta. So L by 4 cos theta equals to next force is N2 and the distance. So the rod length is 3L by 4, but the horizontal distance will be 3L by 4 sine theta. So like this we can equate it like we have done here, and net we will get mg equals to 3N2 tangent theta, right? This is what we have got from the rotational equilibrium. Now let's apply the translational equilibrium. Translational equilibrium means whatever the horizontal forces are balancing each other and whatever the vertical forces are balancing each other. So for horizontal we have N2, right? N2 plus this force, N2 plus N1 sine theta, right? This is the horizontal component, and the opposite force for this is Fr cos theta, right? So this is the first equation that we can form. N2 N2 plus N1 sine theta equals to Fr cos theta, correct? This equation can be written. Now for the vertical components we have mg, which is being balanced by N1 cos theta plus Fr sine theta, correct? So this is the second equation that we can form. Mg is equal to Fr sine theta plus N1 cos theta, correct? Now we have these two equations and we have this one equation where N2 is equal to mg cos theta upon 3 sine theta. From here we have derived it, right? Now what we can do, we can substitute the value of mg from here and put it here, right? So what we will get, or the other way to do so is one second, we can, let me add a page. So we can write mg is equal to what we got here, 3N2 tangent theta, right? The next equation we got is equal to N2 plus N1 sine theta is equal to Fr cos theta, right? This is the second equation, and the third equation is Fr sine theta plus N1 cos theta is equal to mg, right? Now there are 2 to 3 things that we need to understand. We have to find out the ratio N2 by N1, means we have to eliminate mg, we have to eliminate Fr. Now mg we can bring it in terms of N2 and substitute here. So we got Fr sine theta plus N1 cos theta equals to 3N2 tangent theta, correct? Now we have to eliminate this Fr thing. Can we eliminate it from here? Yes, we can eliminate it from here. N2 plus N1 sine theta upon cos theta is the value of Fr, right? From this equation we can write this. Now this Fr value we will substitute here. N2 plus N1 sine theta divided by cos theta into sine theta plus N1 cos theta equals to 3N2 tangent theta, right? Now everything is in terms of N1, N2, sine theta and cos theta. What we can do is we can resolve it. So let's do the same. N2 sine theta upon cos theta plus N1 sine square theta upon cos theta plus N1 cos theta equals to 3N2 sine theta upon cos theta. We can write tangent theta as sine theta upon cos theta. So this N2 terms we can bring it together, right? And here also we can take the LCM. So cos theta N1 sine square theta plus N1 cos square theta, correct? Equals to 2N2 sine theta upon cos theta, correct? We can cancel out the cos theta. We can take N1 common. Sine square theta plus cos square theta is 1. So it is N1 is equal to 2N2 sine theta. Now we have to find out the ratio of N2 by N1. So N2 by N1 is equal to 1 by 2 sine theta, which is our answer for the given question. So guys, these are such type of questions which comes from rotational motion. Generally, the questions coming from rotational motion, you need to focus on either rotational equilibrium, either the net torque, or you have to look about the conservation of angular momentum. So these are the basic concepts on which most of the questions of rotational motion are based. I'll keep posting some questions from chemistry and physics. Please continue to watch our channel and subscribe our channel Magic Mentor, and share it with your friends who all are preparing for NEET and JEE 2026. Stay tuned. Bye bye.